Hi guys, today we're going to be taking a look at page 13 and 14 of the Unit 11 packet. Once again, that's page 13 and 14 of the Unit 11 packet. Now, before we start, I need you guys to recall something that we learned from Unit number 7. That was that for two figures to be similar, right, their corresponding sides had to be proportional and their corresponding angles had to be congruent, right? So in this case, if we want to check to see if two solids, so two 3D figures, are similar, we have to make sure that all of their sides are proportional. So take a look with me at page 13, number 1. Let's check and see if all the corresponding sides are proportional. So if you take a look at that picture, so I'm going to have 12 over 3. That's going to be one proportion. Then I'm going to have the 20 over 5. And then I'm going to have the 8 over 2. Let's check all those fractions. Are those all equivalent ratios? Yes, they are, because they all reduce down to 4 over 1. Thus, the two solids there, those two pyramids, are similar. Now, there's something important that comes from this, and now we're going to look at page 14. If we have two solids that are similar, this is where we're going to fill some stuff in, okay? With a scale factor of A to B. That just means a number to a number, all right? Don't worry too much about what that means right now. The surface area will be similar in the ratio A squared to B squared, and the volume will be similar in the ratio A cubed to B cubed. All right, so in other words, if I have two solids that are similar, in order to find the ratio of their surface areas, I would just square the scale factor. To find the ratio of their volumes, I would cube it. All right, so let's see what the what this will look like in the context of a problem. Okay, let's take a look at question number 4. Once again, which number are we going to look at? We're going to look at number 4. All right, so looking at example number 4, we can very easily figure out what my scale factor is, right? 6 to 3, which I can also write as 6 over 3, and that becomes 2 over 1, or just 2. So my scale factor for number 4 would just be 2 to 1. That would be the scale factor of the regular old dimensions. Now the scale factor for the surface area would be this squared. So the surface area would actually just be 4 to 1, or I could just say 4. And then for the volume, I would have to cube this, and so I would get 8. All right. So in other words, to find the ratio of the surface area of a figure, I would just cube the scale factor, and to find the ratio of the volume of similar figures, I would just cube the scale factor. All right. Now, in this particular case, there are a few other ways they could assess this, right? Take a look, for example, at question number 6. Number 6 gives you something a little bit different, right? They actually give you the surface area and they ask you to go backward and find the scale factor for the regular dimensions, and then they ask you to go ahead and find the volume ratio. So how would we approach this? Okay, so looking at question number 6, here's what we would do, okay? For number 6, we would say, okay, so here's my ratio of surface area, 25 to 4. Or I could write that as 25 over 4. Now, we said that the scale factor, all right, has to be squared to get the ratio of the surface area. So if I want to go backwards, what's the opposite of squaring? Square rooting. So if I square root this, rad 25 is 5, rad 4 is 2, and so my answer for the scale factor is 5 over 2. Then, to find the ratio of the volume, all I would have to do is do the scale factor cubed. So 5 to 2, or 5 over 2, if I cube that, I'm going to get 125 over 8. Once again, how did I get that? Well, 5 times 5 times 5 is 125, and 2 times 2 times 2 is 8. So as long as I cube both top and bottom, I'm good. So in sum, if I know the scale factor for a pair of similar solids, to find the ratio of their surface areas, square the scale factor. To find the ratio of their volumes, cube it.